Hello again, everyone. So we had Richard Wright of Linergy talk about Vulkan development on Apple. He mentioned MoltenVK a ton. So now we have Bill Hollings of Brenwill talk about MoltenVK and the Vulkan portability update. Take it away, Bill.
Thank you. Hello, everyone. Thank you. Too fast. Sorry. So Richard's a hard act to follow. To be honest, he talked a lot about his stuff that I normally talk about. So my presentation may be shorter than expected, but I'm happy to talk about it in detail if people have questions. So we'll get started. I'm going to talk about two things, actually. I guess it's listed here. I'm going to talk about MoltenVK, but I'm also going to talk a little bit more about the portability initiative. Richard touched on that. He talked about the extensions that we're working on, and I'm going to go into a little bit more about what portability is all about. Okay, so as the name sounds, portability is about being able to port your apps to other platforms. If you're going Vulkan to Vulkan, like you've already got a Windows app and you want to go to Linux, you're all set. You just take your Vulkan app, move it over to a bunch of porting, do your typical porting things, and it'll run. But what if you want to go to an environment that doesn't have Vulkan? And the obvious one is Apple platforms, which are quite a significant part of the ecosystem. They don't support Vulkan at all. That's Apple's choice. They have their own proprietary environment. They see a marketing benefit to that. So what happened is, as Richard mentioned, MoltenVK came along and basically took the stance that, well, we've got Vulkan and we got Metal, and they're kind of similar in their model structure, and not at all similar in their details, but similar in their model structure. So can we leverage one of them to emulate or act like the other? And that's what MoltenVK did. It became a Vulkan API over top of the Metal API. So out of that, one of the things that came out of that was the concept of, okay, if we're going to start to do this, what is the best way for the industry to kind of manage an environment where we're talking about one API layered over another? And that's where the Vulkan Portability Initiative came in. And so what does it do? So first and foremost, it addresses that question. It encourages layered Vulkan functionality implementations. And by that, we mean not just sort of saying, oh, we got this fantastic Vulkan environment, and then we've got their poor cousin, which is like the environments that are kind of Vulkan, but not really Vulkan. And they're running really slowly over top of emulation. So back in the old days of graphics, that was a big issue. Not so much a big issue anymore. And so one of the things that the Portability Initiative, the portability team is trying to do is to actually promote the idea that you don't have to have native implementations of every single graphics API out there. You can standardize some common things, common APIs, and then leverage layering to get the APIs or to run on platforms that don't necessarily have the best implementations of that API or don't have those API implementations at all. And I'll talk a little bit more about that in more detail. Then one of the things that happened with MoltenVK in implementing Vulkan over Metal is, as you know, Vulkan moves very quickly. There's tons of new extensions, tons of new features coming out. Vulkan is an incredibly detailed API, fantastic for fine-tuning your app. And out of that, it has probably the most comprehensive set of graphics API technology out there built into the spec. And try as we might, we can't always, when you're talking about a layered implementation, you can't always match everything. You can't cross all the T's and dot all the I's to make sure that Metal is behaving exactly like Vulkan is. And so there's always going to be, well, I shouldn't say always, but currently there are situations, very few and far between, but we'll talk about those in a little more detail, where you either simply can't do something in metal that you can in Vulkan, or to do it in metal would be horrendously expensive or horrendously inconvenient. And so one of the things that the portability extension wants to do, the reason we're introducing these extensions, is so that as Richard talked about, you can then query, you can have a facility to query the environment and say, hey, you know, Richard used the concept of triangle fans. Hey, implementation, triangle fans are a must-have for a Vulkan implementation. Do you actually support triangle fans? And that gives the implementation the ability to say, no, actually, I don't support triangle fans. So I'm Vulkan, but here's the half dozen or dozen things that I just cannot do. So that's a way of allowing the app to be able to query the runtime environment. And as Richard mentioned, by having that query, sometimes things change. So iOS version 8 doesn't do this, but iOS version 17 now does. So that allows, all of a sudden that flag may turn from false to true, because now Metal has introduced a compatible feature that now supports that Vulkan feature that didn't. So it allows the app to act very dynamically when it's running on an older OS versus a newer OS. Another thing that that the initiative is all about is pushing the layers to become as close to conformance as possible. And we've introduced this concept of portability conformance, which says, again, we pass all the tests, we're all there, except for these few tests that are dependent on full conformance. Like, let's say the implementation did not have triangle fans. We would say we are not conformant with full Vulkan, but we are conformant with the portability extension Vulkan, meaning that we are conformant, but we don't support, we may or may not support these things that are actually mandatory, such as triangle fans. But within that scope, the push is to come to get as conformant as possible, or to get full conformance within the scope of portability. And the other thing that Richard mentioned is the understanding that when we're dealing with the portability environment, we need the ability to have tools and extensions and things like that. He talked about the portability queries that you can do to say, am I running on a portable version, or am I running on a full-blown implementation of Vulkan? So MoltenVK running, it's still running on the GPU, but there's a layer in between. We don't have full conformance, so the ability to, as Richard mentioned, to be able to say, am I running on a full Vulkan customized implementation, or am I running on a layered implementation? It's important. And there are layered implementations of Vulkan that are just strictly CPU. So you definitely want to know, am I running on a layer or am I not? Because in that situation, I could be running on a CPU environment, CPU only environment, and then that's going to have obviously drastic impact on how your environment and your app works with the system and its performance and things like that. Okay, so I talked a little bit about layering. This is a really horrendously weird and wonderful slide that talks about MoltenVK was the kind of the initial test bed for layering, but in the intervening years since Vulkan was implemented or introduced and MoltenVK was introduced, there's been actually quite an explosion of this concept and a validation of the whole point that layering is actually quite useful and quite valid. So along the top here, we have, I shouldn't wander too far from the microphone. Sorry about that, I'm excited. Along the top here, we have APIs that I want to use. So if I'm in the rightmost column there at the top, it says DX911. I want to use DX911. My app, my game, it's a few years old and it uses DX911. But I'm in an environment like Apple or Linux or, well, yeah, or something else that doesn't allow me, one of the handheld devices, doesn't allow me to run DX911. So what do? Okay, so there are implementations of DX911 layered that run on Vulkan. So along the top, I've got the API that I want to use. And on the columns on the left, I've got the API they actually have that's available on the system. So if I run DX911 on top of an environment that has Vulkan, I can make use of a couple of products there, DXVK, Wine. If a lot of people are familiar with Angle, so if I've got OpenGLES, I want to run on top of another platform, I can use Angle for that on top of Vulkan. Zinc over there is an interesting thing. It's taking the concept of what Angle does and kind of making it for the whole of OpenGL, which is kind of interesting. So that runs on top of Vulkan. Going the other way, you can say I have a Vulkan app, I have an app that is using the Vulkan API, and I want to run it on a platform that doesn't have it, like we're talking about with Apple. So MoltenVK is down there in the bottom. That's basically saying I got an app that is using Vulkan as its API. I want to run on top of Metal so I can run on any Apple platform. I use MoltenVK for that. Okay. Richard also mentioned Microsoft. Microsoft's actually jumped on this bandwagon pretty hard. So it does three things there, which allows Vulkan, OpenGL, or OpenCL to run on top of DX12. Its product for running Vulkan on top of DX12 is called Dozen. They were initially going to be part of the Portability initiative, and technically still are, although they don't participate. But their interest is in actually getting a fully conformant implementation. So they want to be able to say Dozen is fully conformant with Vulkan. Because they own their own API, they own DX12, they can extend DX12 to whatever degree they need to be fully conformant with Vulkan. And interesting enough, the next step is, what if I have one of these implementations, I've got an API I want to use, and I'm running on a platform that doesn't support that. So you'll see there's a lot of gray and black boxes here. So if I'm, say, I've got OpenGL and I want to run on Metal, what do? Well, I can run it on Microsoft or I can run it on Zinc, let's say, but that doesn't get me to Metal. What can I do then? And then you introduce the concept of layering on layering. So it is technically feasible to say, I want to run OpenGL. That's what my game's written in. I'm going to use Zinc to convert it to Vulkan. So now I have a Vulkan API. I want to run it on Metal. Oh, I know MoltenVK runs on Metal, and it supports Vulkan. So I'm going to layer the two together, go from OpenGL to Vulkan, and then Vulkan to Metal, using Zinc on top of MoltenVK. And believe it or not, that is quite a reasonable approach, and that'll become more and more a part of the ecosystem where people are recognizing that this whole layering concept is quite valid and performant. Excuse me. So I talked a little bit earlier, but I'll talk a little bit more organized now about kind of the activities that the Portability initiative is investigating and working on. One is, the top thing here is a push to make MoltenVK conformant. And by conformant, I mean conformant to the Portability spec. So the idea is we are currently with Vulkan 1.0 as kind of our test bed. We pass 195,000 CTS, which is a standard for Vulkan conformance and compatibility tests. We're currently failing about 285 of those tests. And then in the next point, we want to get that down to 0. So how can we get that down to 0 and say we're conformant? One is the ability to say, implement one of these extensions. In this case, I'm talking about portability subset metal. And I'll talk a little bit more about the difference in a second, excuse me. So the idea there is I say, I can now knock off a whole bunch of those 285s by saying, you know, all those triangle fan tests that are failing, they don't fail anymore because we have triangle fans in MoltenVK, but they used to fail. I'm by allowing the CTS tests and applications to query and say, hey, this implementation tells me now through the portability subset extension that it doesn't support triangle fans. I'm going to allow those tests to be marked as not supported instead of fail. So I can get down to 0 failures eventually by implementing that, and also by doing a couple of other techniques like widening CTS thresholds, where we have the testing environment recognize that not all systems can meet, you know, the thresholds that we might say, like you can be off by a couple of pixels, or you can be off by a few shades of red on this test result. So widening some thresholds. There's the concept of CTS waivers, which is basically saying, due to some bugs on the underlying platform, we cannot actually pass these tests, but they're not really failures. They're more just like, you know, we're hitting platform bugs, and hopefully those platform bugs will get cleared up. So in those cases, we often, or we can sometimes say this platform gets a waiver on those tests because it's just not something that can be dealt with. Then the last thing, of course, is to fix MoltenVK or SpearV which is the software library that MoltenVK uses to convert SpearV into metal shading language. Fixes there that you know, basically turn those failures into successes. Finally, sorry, and then the portability subset metal extension is coming out, and that's a replacement for the portability subset. And the reason, the difference in the naming is pretty well apparent there. Subset, the original KHR portability subset, the original plan for that was to have an extension that covered all of the APIs. So not just metal, but like DX and whatever other, you know, from this thing here, whatever other API you were trying to do. But we realized that that's going to be a horrible mess because DX may be non-conformant and Vulkan in a different way that metal is non-conformant. We'd end up just with a whole checklist of things that some apply to one API, some apply to another platform, some apply to both. So we thought, let's back away from that idea. It's too broad. Let's just say, you know, what are the flags? What are the tests that we need to, queries we need to solve to demonstrate that, or to be able to find out the conformance level of a platform that is just running metal. Okay, and that's, so the provisional portability subset extension is going to get replaced with a finalized and concrete subset metal extension. So it'll just be querying for metal functionality. And I just want to emphasize, and Richard touched on this, the Vulkan samples. A lot of them are already ported to Mac OS, run great. There's a push right now to, and this is covered by the activities of the Portability Group. There's a push here to now move those over to iOS so that I could run samples on Mac OS and iOS. The same Vulkan samples that you run on other platforms are being pushed to run on the two Apple platforms as well, with great success. So they're coming along really well. Okay, now I'll get into MoltenVK as a product itself. So Richard did a little straw poll here about how many people are interested in Apple, in the Apple platforms. And that's pretty well, the results, the quick poll that he did was similar to the results we're seeing in the larger ecosystem. This is the results of LunarG's annual survey. You all probably get a notice from LunarG with a bunch of questionnaire questions, and some of the results are posted here. So as you can see, if you look at kind of like the red ovals there, showing interest in Apple platforms, they split it into iOS and Mac. And you can see we're roughly about 25 to 30% of developers are interested and or working on apps and games in the for the Apple platform. So a significant component of the ecosystem is interested or is running currently on Apple platforms. The note at the bottom there about the Mac OS Vulkan SDK. So if you go to the LunarG site and you go to download the SDK, you get a few options, one for each of the 3 major platforms. We're currently seeing about 5,800, about 6,000 downloads a week of the Mac OS SDK. So that Mac OS SDK, as Richard explains, will cover both Mac OS and iOS. And it's currently growing faster. The download rate is currently growing faster than the other platforms. So for instance, the Mac OS is seeing about 5,800 downloads. Currently, it's about, if you're down, for people who are just interested in Windows and download the Windows environment, the Windows SDK, it's about 38,000. So a lot more, but it's still, in that realm of, 20%-ish of the people, of the downloads are being supported, are being targeted for the Mac environment. And it's, according to LunarG, it's growing. I've seen the curves. Yes, it's growing faster than the others. So the interest in the Apple environment is actually growing. Okay, so who is using MoltenVK? It's actually quite a substantial number of people. MoltenVK is an open source environment. So one of the things we don't have the luxury of having is known clients, because if I'm selling a product that a library that somebody has to pay for, well, now I have a bunch of client names and stuff like that. I know who's using my product. In the open source environment, anybody can download MoltenVK and do nothing with it, do something with it, do everything with it, and we have no idea. So we have one of our challenges is to try to figure out, who's done something when they download it. And this is the sort of current list that I'm maintaining. At the top here is games. So these are games where somebody has downloaded MoltenVK, integrated it into their Vulkan environment, and published a game. So we can see everything from Dota 2 to some of the other games down here, VK Quake and things like that. The next type of developer is somebody who is using either Crossover or Wine, very similar products, to take a Windows game and run it on an Apple, on a Mac. A lot of you may or may not know, underneath the covers of Crossover is MoltenVK doing the actual heavy lifting in terms of actually running that on the Apple platform. Okay, so that's an example, and I'm sorry, I'm going to flip slides here. Or if we go all the way back here, that's a case where somebody who is running Wine or VKD3D, within Crossover, under the covers, Crossover is then leveraging that, doing that double bridging down to Metal using MoltenVK. Okay, sorry for flipping all the way back there. Then we've got a series of applications here in the middle that are not games, so but they're very serious applications. Autodesk, believe it or not, uses MoltenVK for several of its top-notch products. People paying a lot of money to run MoltenVK under the covers, so that's an important validation. You've got significant corporate environments making use of MoltenVK. We've got engines, everything from Google to various gaming platform engines. that use MoltenVK under the cover. So anybody who's using their products and wants to run on an Apple environment is using MoltenVK under the cover. And then we've got a series of emulators. Once again, everything from Switch or Wii emulators to Google actually has an Android emulator that allows you to emulate an Android environment on a desktop platform for the purposes of development. They also have a Mac version of their emulator for people like Richard who are using Mac as their primary development environment and then publishing to Android. And that uses MoltenVK as well. So where are we with MoltenVK in terms of functionality? Currently, we're at 1.2 plus a whole mess of extensions. I misspoke on the next comment there. 5 Vulkan extensions remaining. That actually should be down lower because we are pushing for 1.3. So there's an active push right now to bring MoltenVK up to speed with Vulkan 1.3. And that's where I'm saying we've got 5 more extensions remaining. And you can see on the list on the right, the table on the right, the extensions that are required to go from 1.2 to 1.3 for any platform, platform in the ecosystem. MoltenVK, we're now down to 5 that we need to fill in order to be able to say we run 1.3 functionality. Developers can use the Vulkan SDK on macOS and deploy onto macOS, iOS, or tvOS. That's I'm not stealing any thunder. That's the SDK that Richard talked about earlier. They're making a big push towards iOS as well as macOS in terms of the SDK. And coming soon to a MoltenVK product near you, we've got the first item there is an optional build support for private metal APIs. As you guys probably know, if you've ever tried to deploy to Apple, they sandbox the heck out of everything in their app store. So if you're running on one of the things that you cannot do if you want to publish through an app store is use a private API. So MoltenVK has never tried to break that. We've never said, we've always been a good citizen in terms of Apple. And we've always said, no, we only use public APIs. So only use the legal APIs. We don't hack into their frameworks and say, oh, there's a bunch of slots that I can make use of, a bunch of function calls that I can make use of under the covers, because Apple screens those pretty heavily in the App Store. However, on Mac, if you're not using the App Store, you're kind of free to do whatever you want. You just download an app from a website onto your Mac environment and run it, and Apple doesn't know, and they're not in control of that distribution environment and cannot screen there. So there have been requests to say, hey, there's a bunch of functionality that Apple exposes, but they expose it privately rather than publicly. And so we've introduced this concept where you can create a build of MoltenVK that actually, does allow you to use those private APIs. I mentioned Wideline here. So that was the first sort of test bed we did for that capability. So if you download MoltenVK, build it with a switch turned on during a build setting switch turned on that says, hey, allow me to use the private APIs. You can actually mess around with Widelines, and there's a few others. There's about half a dozen other things where we're making a private API call into Metal frameworks to make adjustments. And you can imagine Apple never wanted to support Widelines, so it was never a part of their public API. But if you think about it, OpenGL and OpenGL ES do support Widelines. So, and as Richard mentioned, on Apple platforms now, all of their OpenGL functionality is implemented on top of Metal. So Metal does support Widelines. They just don't put it as part of their public API. We're working on that push to Vulkan 1.3. Maintenance 4 is an important extension, so that's something that's actually got an open PR, and we're working through the final details. So maintenance 4 is coming very soon. Conformance and portability is a big push to get the CTS failures down to 0 using the concepts that I mentioned before. We want to have, there's a series of bindless improvements that we want to do using the latest metal technology that'll make large descriptor indexing and large scale use of lots and lots of textures a lot more easier in metal. Along with that will come a descriptor buffer, again, using bindless technology in Vulkan. Vulkan 1.3, which I've mentioned already. We've got 5 extensions left. Transform feed PR, the initial drive towards ray tracing with acceleration structures, again, an open PR that's being worked on. So we should see some of these come to fruition in the next few months. There's some improvements in terms of caching performance. And finally, once we get the Vulkan 1.0 CTS test down to 0, we'll start focusing on bringing the current functionality 1.2 or 1.3 once we're there down to 0 as well in terms of CTS conformance. Okay. And then finally, I just wanted to finish up with talk about the structure of MoltenVK as a project. It's open source, as I mentioned. It's free to download. And the key to any open source project ever in existence is getting commitment from people to work on it. So right now, we have a very small team, which is why we always lag behind where Vulkan is. Really, it's I'm the only one working on it full time. We have teams like Lunergy, Holochip, and things like that who get funding from gaming companies or somebody who is using MoltenVK. They want to see specific functionality implemented. The folks at Codeweavers with a crossover product have been actively contributing to it over the years. So we do get some significant contributions, both in terms of code and funding from several environments. And just to say there, we've currently got some active funding for improving MoltenVK functionality and conformance, again, with the idea to try to bring it down, those test failures down to 0, get more of the Android emulator, and other apps are contributing funding to see that those apps run more effectively on Apple environments. And we are exploring in discussions with some people who are keen to see ray tracing happen to try to get funding for that. We do get a bunch of smaller contributions from other users. We have everybody from gaming companies who just need a couple of little features added, so they do a small contribution. We've got university students who are contributing just because they're interested. We've got hobbyists contributing as well. But those are smaller. Those are typically, somebody's just got a bee in their bonnet and they want to see something work better, so they'll do a few nights of work and contribute it. And lastly, of course, we'd like to see more of all of this. So additional funding or contributions are always welcome to an open source project like MoltenVK. And that is it. Thank you for listening on. Okay, questions, anybody?
I was curious if you could share about maybe future mesh shader support. Like, is it planned? What stage is it in? And should we expect it soon or later? Later.
So I didn't talk about mesh shaders here on the list of things to come. because right now it's at the talking stage. There's significant interest in mesh shaders, but it's new technology. A lot of the games that run on MoltenVK are games that have been ported over, so they're games that have been established for a little while. They're not looking to push, to push that kind of level of new technology. Mesh shaders are definitely a part of Metal, so it's completely feasible for us to do mesh shaders, and it just comes down to this slide here, which is we need to get contributions. So if anybody's here is interested in working with mesh shaders and wants to see it happen on MoltenVK, happy to take contributions, happy to talk about it. If you've got a game coming out and you really want mesh shaders and you're willing to fund some development, MoltenVK is actually pretty cheap because it's a small team, dedicated people. It doesn't actually take a lot, to do mesh shaders. It's really just a matter of saying, hey, somebody's got to find a month of free time to do that. I would love to do it. Unfortunately, I've got, these other contributions that I'm actively working on that are being pushed, more in terms of priority. But yes, so the answer is as soon as we can, as soon as we can get people dedicated to it. So I wish, and again, this is, one of the problems with open source is we're completely reliant on somebody actually taking interest and saying, you know what, I'm going to make this happen either by paying for it or by actually sitting down on my evenings and doing that, or convincing my company that, hey, if you want to run this game on Apple, we really need to get mesh shaders put in there. So let me spend some time on that. So we're happy to talk to anybody about any of those options.
So I actually looked into MoltenVK a little bit before, and I noticed that you advertise descriptor indexing, but the update after bind limits are actually quite small. And I found out that this is behind some environment variable. You need to enable that. You need to set the environment variable in order for them to go up. Is that still the case? Because I looked at it like a few months ago.
Are you talking about Bindless right now?
Well, yeah, descriptor indexing.
Yeah. So, yeah, Metal has two mechanisms to bind to the GPU, bind resources to the GPU. One is through discrete, and that's kind of where the whole industry was, a few years ago, to bind discretely. Metal's limitations in terms of quantities are, to be honest, I don't know how they compare to the other binding environments out there, APIs out there, but yeah, they're low. They're, on the order of 30 buffers, 128 textures, and 16 samplers. But they do offer something called argument buffers, which is basically descriptor indexing for Metal. And that allows you to go, the huge, back into the huge scope where you're talking about 500,000 of anything. And that's where I was talking about here. Where are we here? Like the fourth point down there, where improved functionality for bindless resources is something that I'm actively working on. So your question is, you can currently turn on an environment variable or build setting in MoltenVK to say, run me bindless, which it'll do. It'll only do it on Mac, it won't do it on iOS. And there are some limitations because Metal was lagging in terms of its bindless capabilities. With the new Metal 3 stuff, which is now a year old, we have a lot more flexibility there. We'll be able to support iOS, so that's why it's on my priority list to do. Once we get to there, we'll flip it over so that it uses that by default. So you won't have to specifically select, give me bindless stuff. Okay, so hopefully next time we talk, everything will be fixed. Pardon? Yeah. Any other questions?
Hi, about open source contributors. Do you have a small list of easy things that can be done and categorize the task already?
That's an interesting question, because yes, if I'm begging people to come and contribute, it would be very helpful to say, here's the kind of things we want to see done. That's a great idea. I'll try to pull that together. And for those in the room today, here's a list of where we are. Transform feedback is sitting there waiting to kind of get the final pegs put in to make it happen. Argument buffers are actually, it's not argument buffers, sorry, acceleration structures for ray tracing are actively there. So there's a whole bunch of kind of WIP, work in progress, PRs, pull requests out there that please come and have a look at them. If you say, oh, I'd like to, help out with acceleration structures or something, please come and help that. The list here for MoltenVK, Vulkan 1.3 support, we got about 5 to go extensions. So if anybody really wants to come along and implement tooling info or something like that, please join the fray. That'll help us. And actually, interesting because I have had a contributor he's a regular contributor. I shouldn't say he. They are a regular contributor, and they've actually been sort of knocking these off. So like 2 months ago, we were at 8 extensions. Now we're down to 5 extensions that we need to get done because they took the initiative to say, hey, I'm going to do this one looks fun, and this one looks fun, and this one looks fun, and they've come and done that. So yeah, and please, if anybody wants to pick off any of those, most of the things on the list on the left are open PRs. Come and have a look at them. The Vulkan 1.3 support, it's just a matter of picking one of those off and saying, hey, I'll take a stab at this. And there we are. But having a general one for public to say, hey, if you've got some time, please work on these things, priorities. That'd be good. Mesh shaders, for instance, and things like that. That'd be useful. So thanks for the idea. Any other questions?
One last question.
Hi, I have a question about wide lines. Just to confirm, you're talking about the width of a line primitive, correct?
Yeah, like
The GL line width.
yeah, line width. Exactly.
I have a question about that. When it's not exposed in the public interfaces for metal, do you know if Apple Silicon natively supports that, or is that something that's emulated in software? My general question is, do you have any idea or sense of performance characteristics? Yeah.
No, I haven't done a performance test on it, so I don't know. I do know that they have a private API literally called set line width, and you can set it to anything. We have the boundaries we set are 1 to 8, so you can go in 16ths of a step. And it works, but I can't speak to what they're doing under the covers. I know they implemented it. It magically appeared when they introduced, OpenGL on top of metal. So it's very clearly, they've got a bunch of stuff that exists in metal because they need to support it for OpenGL, but they don't want, everybody to have to become dependent on it. They don't want to have to support it, things like that. So they don't make it public. I mean, I think the reason companies don't make things public when it's obvious that it would be useful is just because they don't want to commit to supporting it. Once it becomes public, then they've got to maintain it for the next, X number of years and things like that. So.
All right, I'm going to cut off questions there. If you have another question, please grab Bill in the break.